Welcome to our channel Electron Chemistry Tutorial. I am Vijayalaxmi. Now let us discuss a new chapter of solutions. So from this chapter we will do some objective bits. So first of all, some important points from solutions topic. So let's start. Solutions. First of all, how to define solution? So solution is a homogeneous mixture of two or more components. Homogeneous mixture of two or more components. Okay, so this formation of solution is physical process. So during the formation of solutions, components are not lost their identity. Okay, so that's why that is physical process. So here, based on the components, solutions are so many types. So binary solutions, ternary solutions. Okay, so suppose you can take binary solutions. Binary means two. Binary solutions. Binary solutions have two components. The component which has in large quantity, that is solvent, so which has less quantity is solute. Okay. Suppose you can take salt water. In salt water, salt in small quantity, that is solute. Water is large quantity, that is solvent. Okay. So this solvent can decide the physical state of the solution. The solvent may be gas, that gaseous solution, may be liquid solution, solid solution. And these three types solutions based on this physical state of solute, they are further classified into three more types. So total 9 types of solutions. Okay. So the next, the concentration of how much quantity of solute present in that solution. So we can express it in several ways. So there are major methods, molarity, molality, normality, mole fraction. Okay. So first of all, molarity, how to define? The number of moles, N means moles, number of moles of solute, number of gram moles of solute present in a 1 liter of a solution. 1 liter of a solution is known as simply, so molarity. Okay. So simply here, so this molarity depends on the temperature. As temperature increases, so volume of the solution also increases. According to Charles' law, volume directly proportional to T, no? So as temperature increases, volume increases, but volume molarity decrease inversely proportional. So molarity will be decreases. Clear? So now, how to write units moles per liter? So number of moles, number of gram moles per liter. So liter inverse. Okay. So units also important. Okay. Next, how to find out? Suppose we don't know about number of moles, how many number of moles of solute present in that solution, by knowing molarity. So molarity, so number of moles is nothing but molarity into volume of solution in liters. Suppose volume of solution in milliliters, we can take by 1000. Okay. So molarity also written as, this is one of the formula. These formulas are very important for our objective bits. Okay. So then molarity is equals to what? N by V, no? So N by V nothing but here M is equals to N by V, N into 1 by V. N nothing but number of weight of that solute by molecular weight of that given solute. So instead of N we write here I am writing, instead of N I am writing W by GMW, weight by gram molecular weight into 1 by V in liters. Okay. So suppose V in milliliters, here 1000 only, enough. Okay. This formula is very important. Okay. Next, for dilute solutions. For dilute solution, nothing but suppose M is equals to 1 volume of solution is 100 ml. Then some more water will be added. So then the solution will be diluted. Okay. So for dilute solution, we can use M1 V1 is equals to M2 V2. Okay. So for dilution, after adding that solution, there is no change in number of moles N. So but change in that by dilution, volume increases, molarity decreases. Okay. So here M1 before dilution, molarity, before dilution, volume. So after dilution, molarity, after dilution, volume. Okay. So for mixtures, so maybe 2 or more acids or 2 or more bases are mixed together, then total molarity of that solution, total molarity of that mixture, M is equals to M1 V1 for first solution, molarity of first solution volume of first solution, molarity of second solution, volume of second solution, so on by V1 plus V2 plus V3, so on. Okay. So for mixtures, so this is also very important formula. Okay. Next, for titration and neutralization reaction, nothing but acid reacts with base, no? Acid reacts with base to give salt and water. Salt and water. Okay. So for the titration reactions, we will use for acid. Suppose you can take this is for acids or base, or this is for acid for base. Suppose for example for acid, it's molarity of acid, volume of acid, number of moles of acid. Titrate against with base. So this is suppose you can take base. Okay. So here molarity of base, volume of base, number of moles of base. Okay. Next, when weight volume percentage is given, see here, so weight percentage or mass percentage, weight by weight, W by W percentage means, so weight of solute in grams present in 100 grams of solution is known as weight percentage or mass percentage. Or weight volume means W by V percent. So weight of solute in grams present in 100 ml of, here 100 grams of solution, here 100 ml of solution. Okay, represented by weight of solute by volume of solution into 100. Okay, then volume percent, maybe solute also liquid state, so we can use volume percent. So volume of solute in milliliters present in 100 ml of solution. So simply, so volume of solute by volume of solution into 100. Clear? So ppm. So ppm means parts per million. For a trace quantity of solute present in that solution, so we can use ppm. So number of parts of solute present in 10 power 6 parts of the solution. Okay. So simply total parts of solution also taken 10 power 6, 10 power 6 cancel, ppm nothing but number of parts of that solute. Okay. So now, so these percentages are given, then molarity changes to m is equals to 10 into weight by volume by gram molecular weight of that solute. So simply here weight by volume means W grams of or X grams of solute present in V volume nothing but 100 ml of solution. So simply take this formula, m is equals to weight by volume, the gram molecular weight into 1000 by 100 ml. So simply, so m is equals to weight by volume percent into 10 by gram molecular weight remaining. Clear? Next, if a weight percentages are given along with the specific gravity density, then formula changes to, so this formula changes to m is equals to same 10 into weight by weight into d density or specific gravity by gram molecular weight of that solute. Clear? So simply weight by weight, volume by weight, nothing but suppose 10 percentage of weight by volume, nothing but here you can take 10, or 4% means you can take 4. Okay. So here also same, suppose 2 percentage of weight by weight is given, you can take here only 2. Clear everybody? Next, number of molecules. Here number of moles nothing but m into V in ml by 1000, no? So number of molecules or atoms or ions. So for calculating the number of ions is nothing but number of ions or atoms or molecules nothing but number of moles into Avogadro number, no? Number of moles nothing but, so this one Avogadro number. I means I factor. For ions, I factor maybe changes. Okay, maybe 2, 3, 4, 5. So that will discuss in next class. Okay, these are important formulas. Let's do some important objective bits on these formulas. Okay, so here first problem on molarity. Calculate the molarity of 4% of weight by volume NaOH solution. Okay, So weight by volume is given. What is the formula? M is equals to 10 into weight by volume of that solution by gram molecular weight. Okay. So simply 10 into weight by volume is given as how much? 4. 4 by molecular weight of that NaOH, how much? So for sodium 23 grams plus 16 grams for oxygen, for a hydrogen 1 gram, total 40. Okay, so 40. So simply 0 0 cancel, 4 4 cancel. So what is that? 1 m. 1 m. Okay. Suppose you didn't get you this formula. Simply you can use what is the molarity formula? Molarity is equals to weight by gram molecular weight into 1000 by V in ml. Okay. Now what you have to do, one thing here, 4% of weight by volume means 4 grams of solute means NaOH, here solute is NaOH, present in percent means 100 ml of solution, 100 ml of solution. Simply here V is taken as 100 ml, W is taken as 4 grams. Simply 4 into gram molecular weight, same 40 into 1000 by 100. You can simply, what you get, 4 into 10 by 40, no? Same, no? Okay. So simply we will get what? 1 m. Clear? Next, calculate the 3.6 grams of hydrochloric acid HCl is dissolved in water to give 2 m solution, molarity of the solution to, what is the volume of solution in milliliters? Okay. So simply what is the formula? Simply what he has given, first of all you have to write weight is given as 3.65 grams. We have to calculate volume. So then which solution is given? HCl, gram molecular weight of HCl how much? For hydrogen weight always 1, chlorine 35.5. Okay, simply 36.5. Okay. Now molarity also given 2. So what is the formula? Molarity is equals to weight by gram molecular weight into 1000 by V in ml. We have to calculate this one. So simply V is equals to weight by gram molecular weight into 1000 by molarity. Have to change the formula. Weight is given as 3.65. Gram molecular weight is 36.5. 1000. Molarity is given as 2. Okay. So one's how many times? 500 times. Okay. So simply this is one's 10's. Okay. So 0 0 cancel. So 50 ml. So what is the volume? Volume of solution is 50 ml. Clear? Next, third problem. How much water must be added to 1 liter of decamolar NaOH solution to get decimolar NaOH solution? So first of all, decamolar nothing but decamolar means molarity is equals to 10. Decimolar means this decimolar means m is equals to 0.1. Suppose centimolar is given, molarity is equals 0.01. Millimolar is given, then molarity is 0.001. Okay. Suppose semimolar means 0.5. Simply molar solution, nothing but molarity is equals to 1 only. So you have to remember this for different examples. By adding water, solution will be diluted. For dilute solution, what is the formula? M1V1 is equals to M2V2. Okay. So before dilution means what? 1 liter of that solution of decamolar means here M1 is given as a deca, V1 is 1 liter, nothing but 1000 ml. Okay. Next, to get decimolar solution means M2 is given as 0.1. Okay. Next, V2 we have to calculate. After calculating V2, so V2 minus V1 nothing but we will get how much water should be added to get that solution. Okay. Now, see here 10 into 1000 is equals to 0.1 into V2. Then V2 is equals to how much? 10 power 4 by 0.1, that is nothing but 10 power 5. Then how much water should be added? Should be added means we'll get by V2 minus V1. So V2 minus V1 nothing but V2 is calculated as 10 power 5. V1 is given as 1000 means 10 power 3. Okay. How much? 10 power 2 only, nothing but how much water? 100 ml of water should be added to get what? Decimolar solution from decamolar solution. Clear? Fourth problem. This is previous bit, JE means 2013. So listen to me carefully. Molarity of a solution obtained by mixing of 750 ml of 0.5 m HCl with 250 ml of 2 m HCl. So both are HCl's with different concentration, different volumes mixed together. Then total molarity is equals to what? M1V1 plus M2V2 by V1 plus V2. Okay. For first solution you can take M1V1. For second solution you can take M2V2. Okay. So for first solution, molarity of the solution obtained by mixing of 750 ml of 0.5 m HCl with so first solution concentration molarity is given as 0.5, volume given 750. Okay. Plus next 2m into 250 by V1 750 ml plus 250 ml. Okay. So 750 plus 250 how much? 1000 ml. Then how much here? 0.5 into 750 means 375 plus 250 to 500. Okay. By simplifying this, 875 by 1000, 0.875 what? M molarity. Clear? Next, fifth problem. So this is previous MSET AP MSET 2016. 40 ml of X molarity of KMnO4 potassium permanganate solution is required to react completely with 200 ml of 0.02 m oxalic acid solution in acidic medium. The volume of X. So this is what titration reactions. Okay. Did you remember this? It was done in volumetric analysis. So oxalic acid titrate against with pink color solution of KMnO4 potassium permanganate. Okay. So we need to write chemical equation. So KMnO4 so reacts with oxalic acid H2C2O4 in acidic medium means we have to take one test tube of sulfuric acid. So react together. So to give potassium sulfate, manganese sulfate, CO2 plus H2O. So this is a chemical reaction. So 2 moles 2MnSO4. So 3 moles of H2SO4 we have to take, and 5 moles. Here 10 moles, 8 moles. Okay. Now, so this you have to compare oxalic acid and KMnO4. For molarity of KMnO4, M1 is given as X. Volume V1 is given as 40 ml. Number of moles, how many moles required here? 2 moles. Now here M2, oxalic acid molarity is 0.02. Volume is given as 200 ml. Okay, so the number of moles required for that reaction 5 moles. So what is the formula for titration reaction? M1 V1 by N1 is equals to M2 V2 by N2. So Mn is given as X into 40 by 2 is equals to 0.02 into 200 by 5. Okay. So by simplifying this, simply here X into 40 by 2. Here 2 zeros means 2 2s are 4 by 5. Here 4 1s are 4 10s are. 1s are 5s are. 5 5s are. Clear? So then how much? Then X is nothing but what? Only 1. 1 M. Clear? Next problem, 6th one. This is also previous bit JEE 2021. Listen to me carefully. The exact volumes of 1M NaOH, molarity of NaOH solution is 1, required to neutralize as 50 ml of 1M phosphorus acid H3PO3 solution and 100 ml of 2M hypophosphorus acid solution respectively. Okay. So what you get simply here, NaOH reacts with both H3PO3 and H3PO2. Okay. So for both reactions we have to calculate how much volume of NaOH required to that reaction. Okay. First of all, for first reaction, NaOH reacts with H3PO3 gives Na2 HPO3 plus H2O. So 2 moles of sodium required. So here you have to write 2 moles of NaOH. Okay. M1. For first M1, for M1 NaOH, M1 is given as 1M. So V1 is given as V1 we have to calculate. N1 is required, 2 moles required. Okay. Now here M2 also 1, V2 50 ml of H3PO3, N2 only 1 mole. Okay. Now see, write down. So find out M1 V1 by N1 is equals to M2 V2 by N2. That implies M1 1, V1 we have to calculate, N2 2, M2 also 1, V2 50, N1 also 1. Okay. Simply we will get V1 is equals to 2 into 50, that is equals to 100 ml. Okay. So for this reaction 100 ml of means 100 ml of NaOH reacts with the H3PO3. Okay. So to give sodium hydrogen phosphate. Okay. For second reaction, for second condition, under 100 ml of 2M H3PO2 means the same NaOH reacts with here H3PO2 only, gives rise to NaH2PO2. plus H2O. So only 1 mole required here. So how to find out here 1 mole, here 2 moles? See here. Listen to me. H3PO3 means write down structure of H3PO3. We should have an idea on structures of H3PO3 and H3PO2. Okay, write down H3PO2 also. P double bond O, OH, H, H. See here, hydrogens are connected to the oxygens. These hydrogens can replaceable by sodium ions only. Okay, so that is basicity of that acid. Okay, but here only one hydrogen connected to that oxygen, so that's why this only one hydrogen can replaceable by metal ions like sodium. Here metal is given as sodium, so sodium ions. So only here 2 hydrogens are replaceable, that's why Na2, here Na, H here. Okay, so this hydrogen not replaceable with any metal ions. Okay, so but only oxygen connected hydrogens can replaceable with metal ions. That is basicity of that acid. It will be clear in normality. Okay, now simply remember that OH means hydrogens are connected with oxygen, that hydrogens can be replaceable with metal ions. So that's why here we need 2 sodium ions. So but here only N, so 1 sodium can replaceable, that's why we need only 1 mole of sodium hydroxide. Clear? So now for here write down again M1 1, V1 we have to calculate, N1 1 only. Now here M2 given as 100 ml of 2M. So 2, V2 100 ml, N2 1 only. So now calculate M1 V1 by N1, M2 V2 by N2. Clear? M1 1, V1 we have to calculate, N1 again 1, that is equals to M2 2, V2 100, N2 1. So then V1 is equals to 2 into 100, 200 ml. Okay. So for this first reaction we need 100 ml of NaOH. For second reaction we need to take 200 ml of NaOH for completing the reactions. Clear everyone? Next 7th problem. This is previous bit 2021 mains. When 35 ml of 0.15 m lead nitrate solution is mixed with 20 ml of 0.12 m chromic sulfate solution, dash 10 power minus 5 moles of lead sulfate is precipitate out. Okay, so what he has given, lead nitrate reacts with chromic sulfate. Write down that equation first of all. Lead nitrate plus chromic sulfate gives rise to lead sulfate plus chromium nitrate. Okay, now 3 moles of sulfate, no, 3 Pb, 3 and O2. Okay, next here 2. He has given volume of lead nitrate is given 35 ml, molarity also given 0.15, and next here chromic acid molarity is given 0.12, volume also given 20 ml. Okay, but what is it? So dash 10 power minus 15 moles of lead sulfate is precipitated. We have to calculate lead sulfate moles only. Okay, so by this equation, suppose it didn't give anything these values, so simply by this equation, so 3 moles of lead nitrate give 3 moles of lead sulfate only by reaction with chromic sulfate. But he has given volume of lead nitrate and what? Molarity of that lead nitrate. Okay. So according to equation, number of moles of both lead nitrate, lead sulfate same. But by this given data, we have to calculate that lead nitrate number of moles. Okay. So number of moles of lead sulfate, number of moles of lead sulfate is equals to number of moles of lead nitrate. Okay. Now number of moles nothing but, see here, molarity is nothing but N by V, no? Number of moles means M into V. So simply number of moles for nothing but M into V in milliliters, volume in milliliters, that's why you can take 1000. Okay. So molarity of lead nitrate is given as 0.15, volume is given as 35. Sorry, 1000 here, 1000. So by simplifying this, 0.005 or 525 into 10 power minus 5 moles. So 10 power minus 5 already given. So you can select 525 only. 525. Clear? Next problem. Number of glucose molecules present in 100 ml of centimolar, means volume is given as 100 ml. Molarity is given centimolar means 0.01 m. Number of glucose molecules present in that solution is. So simply number of molecules, any molecules, nothing but here glucose molecules. Glucose molecules can be calculated by formula M into V by 1000 into Avogadro number into I factor. Okay. So molarity is given as 0.01, volume is given as 100 by 1000 into Avogadro number, we know very well how much, 6.023 into 10 power 23. I factor for glucose is not decomposed to give, not ionages, that's why I factor is always 1. For undissociated compound, I factor is always 1 unity. Okay. Now how much? So 10 power minus 2 here, 10 power 2, then cancel mutually. 6.023 into 10 power 23, 1000 will become 10 power minus 3. 6.023 into 10 power 20 molecules. Which molecules? Glucose molecules. Clear? See you. These two problems homework for you. I will give you int and I can do ma. Okay. Next, calculate the weight of sodium carbonate present in 100 ml of 0.1 m. Molarity is given as 0.1. Volume is given how much? 100 ml. So we have to calculate weight. So then what is the formula? Molarity is equals to weight by gram molecular weight into 1000 by V in ml. Okay. So we have to calculate weight here. So gram molecular weight, I will give you gram molecular weight of sodium carbonate. How much? 106. Okay. You have to calculate weight of the solution and so write down answer in the chat box. Okay. Next 10th one also you have to do ma. A 30% weight by weight of solution of NaOH molarity is 5. The density of the solution. So what is the formula? Molarity is equals to 10 into weight by weight of that solution into density by gram molecular weight of that solution, NaOH solution. Okay, we have to calculate density. So the molarity is given 5, then weight by weight percentage is given as 30. Gram molecular weight, how much? Gram molecular weight of NaOH. Gram molecular weight of NaOH is 40. So all are substituted here. So you will get density. Have to do and write the answer in the chat box. Okay. That's all for this video. In the next video we will do remaining methods for find out the concentration of solution. Okay, so did you like this video? Please like, share this video and subscribe my channel to get more videos. Thank you for watching this video. Thanks a lot.